All right, working with applications of Z-table. Applications of a Z-table. The progression that we have done initially was you were just giving a value, and you had to calculate an area looking at your Z-table or a probability looking at a Z-table. That was the first thing that we had to do. What we started yesterday was you had to do the calculations of a Z-score. You had to read a problem. You had to determine the value that you're looking at, the mean of the value, and the standard deviation, which is given to you. Calculate your Z value, do your bell-shaped curve, and then go and calculate an area from the Z table. Had a worksheet that involved working with these calculations, 3 problems within the problem. Is there any questions that you have on any of the problems? Any questions you have within the problems? Once again, mathematically, it's not an ooh and ah type of thing, but it is just all new to you. Nobody here has ever seen a Z-table. Never. We've worked with a Z-score a little bit, but we've never seen a Z-table and look at problems like we have here. So mathematically, it's not an overly complex thing to do. It's just new processes to do. And when there's new processes that you're doing, that's when it's important that you get repetition and get a little bit of practice with it. Because without that little practice, you won't get to learn the process of solving a Z value and looking at a Z table. Questions, anything? Hopefully we're keeping up with the work. Today we're going to put the process in reverse. And we'll get a little practice. We'll do a problem here just to review what we did yesterday. We'll take a look at it's the average cost of eating out at a chain restaurant. We're going, of course, Applebee's on date night here. Is $13.75 per person. If you're going on a date, this would be $27.50 for 2 plus your tip, approximately $4. Cost would be $31.50. Okay, we're taking somebody on a date. We want to make sure we have enough jingle in our pocket to be able to pay the bill. Okay, let's take a look at, let's see, we'll take a look at this one. If you're taking a date out to eat, what is the probability that the bill will be between $27 and $35? Okay, what is the probability that your bill will be between $27 and $35? Well, what we're going to have to do is we're going to have to calculate a Z value for your $27, and we're going to have to calculate a Z value for the $35. We have the mean is 31.50. We have a standard deviation of $2. So we have a standard deviation of $2. We have a mean of 31.50. Okay, so calculate a Z value for both of these. Do your bell-shaped curve. Go to your Z table. Find the 2 values from your Z table. And check your answer with somebody around you. Once again, your Z value, make sure that you round to the nearest hundredth, 2 decimal places. You should have one Z value that's going to be greater than 0, one Z value is less than 0. You should have one positive, one negative. So you have one value that's greater than the mean, one value that's less than the mean. All right, if we take a look at the Z values, Noah, what do you have for Z value for 27? Negative 2.25 and 35, Ethan? 1.75. Those are our two Z values. From there, we go to our Z table, and we calculate the areas. We look at your areas for the Z table. For negative 2.25, we're looking up 2.25. Okay, and once again, are we good with these numbers here? Yeah. All right. If we look up our area for negative 2.25, Paul, what do we have? 0.48 what? 78 for 2.25 and 1.75. What do we have for 1.75, Grace? Okay, so we found these two areas. This is my Z value for negative 2.25 and 1.75, which translates to $27. And this one translates to $35. So we're looking at the percent of scores or the probability that we're going to be in between these two values. So what are we going to do with these two values, Maddie? Add them together. So we have 0.4878 plus 0.4599. What do you come up with? 0.9477, which means the probability of us having a bill between $27 and $35, there is a 94.77% chance that our bill will be between $27 and $35, which is a pretty good possibility that's going to happen. The translation to this also is why there's a 94% probability of that happening. That means there's 94.77% of the bills are between this $27 and the $35. Why the probability is there? That just means that 94% of the bills are between those two quantities. That's why we have that probability. That's why we have a percent of that. The people aren't buying too many milkshakes. They're not buying too many extra fudge, double fudge sundaes at the end. Okay, that's going to keep their bill between $27 and $35. They're not buying the cheese sticks appetizers at the beginning there. Okay, so 94% of those bills are going to be between $35 and $27. So if we take a look at this, we have 94.77% of the bills are there. That's why we have a probability that's there. Now, let's take a look at turning this process into reverse. Our Z-score is calculated by value minus mean divided by standard deviation. Value minus the mean divided by standard deviation. If we would multiply both sides, do some algebraic skills, by our standard deviation, that will cancel these out here. So what we're left with is our standard deviation times our Z-score is equal to our value minus our mean. If we add the mean to both sides, what we're left with is this value is equal to the Z-score times the standard deviation plus the mean. So if I want to calculate a specific value that corresponds to the Z-score, what we've done up till now is we've taken the Z-score, we've taken our value and calculated the Z-score. And everything we've done so far, we've taken the value, calculated the Z-score, went to our Z-table. Now what we want to do is we want to take the Z value and push it back into the value. What value corresponds to that? So we want to be able to calculate a value given a percent or a Z-score. For the previous problem, what would be the boundary values for the middle 10% of the bills? In our previous problem, the mean was 31.50. Our standard deviation was $2. That was the previous problem. We want the boundary values for just the middle 10% of these bills. So what does that look like on a bell-shaped curve? Here's our 0 value. We want the bills that are the middle 10%. So we want the bills that are the middle 10% of all the bills. And we want to know these boundary values. So what we're doing is we're looking for a boundary value. We're looking for this value right here. So we're looking for X. And what we're given is we want the middle 10%. We know the mean and standard deviation. We know this value, this value. What we don't know is a z-score. And that's what we had to figure out. Well, if I'm talking about this middle 10%, that means my area is 0.10. Once again, we're just talking about probability, going back into area. If I have 10% of the bills, that means my probability that my bill is going to be between this value and this value is 10%. That means my area right here is 0.10. Looking at symmetry. What does each one of these areas have to be? Not 0.5, 0.05. So this area is 0.05 and this area is 0.05. If I add 0.05 plus 0.05, I get 0.10. Where do I find area on a z-table? This middle section right here. This middle section gave us the areas. So we're looking for an area that's 0.05. So we go into the body and we're looking for, we're not going to get an exact value, but we can get a close enough value, the closest value to 0.05. Or 0.0500. So we look in our table for the closest value to 0.0500. What two are we in between? Ella, what two are we in between? Okay, well, let's just look at the areas first. Just go into the terrain. You're exactly correct. Just find these values here. Okay, 0.0478 and 0.0517. Which one are we closer to? Are we closer to the 0.0478 or 0.0517, Justin? 0.0517. You can think about we're 17 away here. We're 22 away here. So we are closer to this value right here. So that's going to be the z-score that we're going to look at. So if we take a look at 0.0517, what is the z-score that corresponds to 0.0517? AJ? 0.13. because I have to go to my left. I'm at the 0.1 there. Then I go to the 0.0517. That gives me 0.03. So my z-scores, this is going to be a positive 0.13. This will be a negative 0.13. So knowing my z-scores, I now know my z-score, I can find my values. So I have my value is equal to my z-score, negative 0.13, times my standard deviation, which is 2, plus my mean, 3150. And then we have a positive 0.13 times 2 plus the 3150. So we can find two boundary values. Rachel, what do you get for your two values? $31 point what? So to be in the middle 10% of my bills, my middle 10% of the bills are between $31.24 and $31.76. $31.76 and $31.24. Okay, let's take a look at the middle 20%. Okay, middle 20%. So what's our areas going to be in each one of the sections? Okay, if I have 20% and I have symmetry, that means I have 10% in each. So I find my areas in each one of those sections again. I go to my Z table, find the closest area to my areas that I have here. What is your two Z values? And then calculate your values. Check your answer with somebody around you. And go down and do the middle 50%. Leave some room because I'm going to throw in another problem. If we look at the first one, the middle 10% or 20%, our Z value, our Z table value that we're going to use is going to be what, Skylar? Just give me the Z values off of that. What's the Z value for the 0.1000? What Z value did you use? Okay, so the Z value that goes with that, 0.25. So we have negative 0.25 and a positive 0.25. So we have our value, our Z value times our standard deviation, negative 0.25 times 2 plus the 31 50. And a positive 0.25 times 2 plus the 3150. So our two values that we come down to are what, Emma? And I'm sorry, what? Okay, so we're between $31 and $32. The middle 50%, our Z values that go with the 0.2500, Jack, what are the Z values? So we got 0.2500, so we look in here, and we're between the 0.2486 and the 0.2517. Okay, so we're going to use one that's closest to it, which is the 0.67. So once again, we have value is equal to the z-score, negative 0.67 times 2 plus the 3150, and value is equal to positive 0.67 times 2 plus 3150. Our two values that we come up with, Jenna, are what? 32 point what? 84. So $31.16 and $32.84. What if you want to show you the big spender? And you want to show you're in the top 5% of the bills, which means you're trying to show off there, I'm the big spender. Top 5% of the bills. Now, if we take a look at our bell-shaped curve, we are saying this is what we're looking at. And we're looking for the Z value for the top 5%. So my area there is 0.05. What is the area that we look up in the Z table? Q? 0.45. If we take a look, this being 5%, that means this is 45%, because this has to be a total of 50%. So this area here is going to be 0.4500. So if we take a look at 0.4500, well, the 0.4500 is exactly in the middle between two values. Traps. You got 0.4495 and 0.4505. So you're 5 away. Well, these are, once again, irrational numbers. If you take it out a few more decimal places, you're going to be closer to the 1.65, which is the 0.4505. So the Z value that you want to use is 1.65. Bless you. Once again, it takes, if you'd have to go out a few more decimal places. For our purposes right now, if you use 1.64 or 1.65, I would count it correct. Eventually, we'll go into a little bit more defined when we get into the next chapter. We'll use the 1.65. and it'll be a little bit more defined to you as the 1.65. But you still deal with your value is equal to your Z value, 1.65 times the standard deviation, plus your 3150. So to be in the top 5% of the bills, you want to show off and be the big spender. What would your bill be? Sarah, what would your bill be? Oh, we're just looking at the top end one. We're not looking at the negative one. We're just looking at the positive one. $34.80. So you'd be your big spender. You want to spend above $34.80 to show that you're in the top 5% of the bills. All right, you have 3 problems, which you have 2 that are mixed in, a couple of them that are combined together. Once again, utilizing the same idea. Looking at your percent, do your bell-shaped curves, put your percents in. Sometimes it's easier to look at these as percents to begin with. Look them as percents to begin with, and then convert it into a decimal that will take you to the table. Solutions are provided for you. You have about 5-6 minutes here. The rest of the time is yours.